First of all, thank you to John and the whole OWASP team to give me the opportunity to present here again. I was here last year as well, but yeah, it's great to be here again. So just a little bit about myself. So I'm a security consultant working for one of the leading financial institutes of New Zealand. Penetration tester, I do web and mobile pen testing. Some of the InfoSec certificates that I've done. Proud of OSCP and AWPDX. Play cricket and pool in my free time. We can probably have a game after this talk if you have time. So this was me. Every time you get that email from OWASP that your talk has been accepted. At this time, I was actually on the bus when I read that email, and I was like, oh, yes. And the people were next to me were like, what's wrong with this guy? Another reason not to read your email when you're on public transport. But yeah, so again, this is what we will cover in this talk. Because of the limited time, I will only be covering Android operating systems, so I won't be covering iOS. So we will be covering the Android architecture. I'll give you a crash course on that because that's really important before we can, get to the reversing part of Android. Obviously, we will cover the type of tools that we need to reverse engineer that app. Obviously, the compilation and the decompilation process of that app. And the last section that I've added in my talk is around how to protect your applications from reverse engineering, or how you could actually add more layer of defense in your applications while you're developing or before you're publishing those onto Google Play Store, because it'll be covering Android. But you can actually take these learnings and you can also apply these in iOS, so this should be fine. So the main purpose of this talk, when I was actually thinking about submitting my CFP last year, was that because the mobile application security is not at the same level as web application security at this stage, because the traction in mobile application security is not at the same level as web app security. When you are in the market and you want to do some certificates even in mobile application security, you don't really see many. So that's why I thought, okay, I probably will do a talk on mobile application reversing, and then probably get people excited about mobile application security and why reversing is important. So that was the main reason why I picked this talk. First question is, people would ask you why you should actually do reverse engineering in the first place. So here it is. So you actually know before you publish your application to the App Store that what's actually inside your application before you're publishing it. Because what's happening, what I've seen in the past and from my experience, that people are leaving their intellectual property, that could be a code or the username and passwords, could be secrets, API keys, and whatnot in their source codes. And once your application is in the Play Store, it's out there on the internet, so anyone can download, decompile it, and can find this information if you've hard-coded it. So that's why you have to have a gate in place to check and look for these things. And if you are doing DevSecOps, or DevOps, you can actually build these gates in place so you know what you're looking for before you're releasing your application on these platforms. And also, you probably want to know what attackers can do to your application. So that's why reverse engineering is also important. So you could actually do it in-house before someone else does it for you. So obviously I want to put a reference there for my talk. So I will be covering these last three components of the OWASP top 10 for the mobile, number 8, 9, and 10. So that's where I'm focusing today. Reverse engineering, code tampering, and the extraneous functionality. So let's start. So what is reverse engineering? There you go. But that's the definition you can find on Google, and you can find what reverse engineering is. But today, what I'm going to do is we're going to look into an Android app. We'll be pulling the Android app from an installed app on my phone. Then we will take this APK file, and then we will look at what actually makes up this APK file. And then we will unzip this APK file, we'll decompile it, we'll make some changes to the source code of this app, we'll then recompile it, sign it, install it, we'll sign it, optimize it, and then we will install it on the mobile. So that's what I will be covering. Just want to give you a quick crash course on Android, because this is really important to understand what components actually make up an Android application. So here we go. Just to give you a little bit of information or the background on the compilation process. So this is the compilation process of a C program. You've got, when you write a program in C, obviously you store it or save it with the .c extension. Then you compile that program, and then you get the assembly code, and then you use an assembler to do another output, and then you get the executable file. The problem with C is, because the compiler of C language is so sort of tightly integrated with the operating system, you can't port this code to another platform. So it's a platform-dependent code. So when Java came along, Java sort of fixed this issue, because the Java bytecode, which you get after compiling Java, is movable, because you've got this Java virtual machines running on every platform. And you could actually, if those platforms are running JVM, you could just move that Java bytecode onto those platforms, so you've got more flexibility. As a developer, you just want to write once, so your code works across different platforms. So you've got this JVM, works for OS X, works for Linux, and works for Windows. So that's sort of the principle of Android. So that's why I put this up here, and I'm just comparing that with the older Android architecture. You could see when you're writing your Android app, obviously you can write it in Java, C, C#, or other language. And then once you compile it, then you get a bytecode, and then that bytecode gets compiled into what we call it as the DEX format, short for Delvic executable. And then that Delvic executable runs on these I've just got like 3 hardware manufacturers, but could be any manufacturer, on their DVM, which is called the Delvic virtual machine, which is supportable. So the DEX code is supportable on those Delvic virtual machines, and you can run that. So as a developer, you're only writing one code, and you're publishing one app on the App Store, but then you can use the same app on Samsung, Huawei, or any other Android platform. So that's as I mentioned on the top, it's the older compilation process of Android. In the next slide, I just want to give you a little bit of more information on the new one. So in the new Android compilation process, what happens, you've got the bytecode, you get the DEX code after compiling it, but after that, you further compile it to get the optimized Delvic exchange code or executable code, and then you run that on ART. Now these days, all of the hardware manufacturers, they use ART, which stands for Android Runtime. And the difference between these two compilation processes, on the older versions, every time you would launch a new app, your app will compile in runtime. That means your app will be unresponsive until it has finished the compilation process. Whereas in the new versions of Android, when Google looked into it, I think since Lollipop, they introduced Android Runtime. And what happens now is when you install a new app, it takes a little bit longer because it's already optimizing the code for you. So you don't have to do the real-time compilation. It's already been done. So when you install a new app these days, it just takes a little bit longer before you can install it because it's optimizing that code in the back end. So that's what ODEX and the new compilation and the old compilation process is all about. So these days you run ART, and in the previous days you used to run JVM. So that's why, your new phones are more faster because that code is already compiled. So let's coming back to our main topic. What is an APK? So APK is pretty much the executable version, .exe version of Android. It's a zip file. So you could just simply run an unzip command and you can unzip it. It's a jar file, which is like archived. You just need to run unzip, and you can unzip this. Has all sorts of different type of resources, which makes up this APK file, which are, I'll just write them here. You've got Android manifest file, you've got the classes.dex file, resources, and other files. So the Android manifest file is like the key file of your APK. I'll just cover these one by one with some examples and how these files look like in the next slides. So Android manifest file. So when you, because this is such a key component of Android platform, because when you install or when you build your application, all of the permissions that you're giving while you're installing the applications are recorded by this application. So it also holds all of the information around that app. Say, for example, you're calling some Android APIs internally, so all of that's been recorded in the Android manifest file as well. Also, it's got all of the activities, all of the intents, everything that your app requires to run is in the manifest file. It's in an XML format, so that's what it looks like. So when you unzip the APK file, that will be there. The next one is the classes.dex file. As I was referring to that the previous slide, so the classes.dex file is just an executable bytecode, which will be run by your Android ART. Res, this is another folder in your APK file. Once you extract that, it will have all of the bitmaps and the layouts that your application requires to run. And that's what I've done. I've just like sort of unzipped the APK file, and you can see all of this information inside that APK file. And some of the other few files that I would like to cover are the resources.asc file and the meta.inf file. So the top one holds all of the resources in a binary format, and also has all of the information around images, strings, and other stuff. The meta information is sort of holds the integrity check of your application. So if you're actually modifying, someone is trying to modify your application, it will hold a record of that, the meta.inf file. I don't want to go into too much detail like how it signs it, but there's like a whole heaps of documentation available on Android project. So this is something really important, which is called Smali, and I'll explain why. So you've got a DEX file, which is the binary version which will run on the Android phone. The Smali, what it does is, because you won't be able to do anything with the DEX file, so obviously the smart people, they found these compilers and decompilers, or sorry, assemblers and disassemblers. You could feed DEX file to the disassembler and you can get a Smali code. The way I understand Smali, it's actually similar to your assembly. So that's assembly for Android. Because if you're making changes or you want to read the code, you won't be able to go into DEX and read it. You come back to the Smali, you look at it, and you will read that code and make sense of it. And that's how the Smali code looks like. Starts with .public and .class files. I know, that's what you're thinking, right? So yeah, we're just coming to that point. I just want to sort of build it up so you understand the basics of an Android application. Yeah, so another thing is, this is the key problem when it comes to Android, because you've got millions of tools on the internet, and we just don't know which tools to use when, or what tools to actually use to do this. So what I've done is I've just, based on my previous experiences, the tools that I use on daily basis, I've just listed them here, so you could just use them. Most of them are free, open source, and you could just go online and you can use these tools. Okay, so obviously if you want to do reverse engineering, you need either an Android phone or you could use an emulator. That's fine. It doesn't have to be a phone, could be a tablet too. Of course, an APK file, you could go and download one from OWASP's Droid project, because that contains all of those top 10 vulnerabilities. Obviously, if your friend can give you an APK file to do that, that's great. This tool, APK tool, is probably one of the best tools out there for compiling and decompiling an APK file, which we will be using. Dex to jar. So that dex format file, which is the classes.dex file I was talking about, you could just feed that classes.dex file to this tool, and it can give you a nice Java jar file. And then you can open that jar file into JD GUI, and you can just see how that code sort of looks like. JetX, similar to dex to jar, can help you convert the dex file into jar format, but it has ability to do symbol search and all of that. JD GUI, really important because once you have the jar file, how to view it, you open that in JD GUI. So you could see how that Java code looks like. You can make sense of that code. You can go back to Smali, and you can make changes there. Android Studio, similar, it's an IDE environment for developing Android applications. That's ADB. You can use that to install and uninstall applications from the mobile phone once it's connected to your laptop or to an emulator as well. And once everything is done, we have to sign the application, and I'm using APK sign in this example, but you can also use jar signer as well to sign your application, because if you don't sign the app and you deploy it on the phone, it's not going to do anything. Android would just, your phone wouldn't detect it. You won't be able to push it to your phone anyways if it's not signed. So in this example, I'm just going to shout out to my friend because he gave me his app that he developed to reverse engineer. So I just want to give him a shout out. So he gave me this app. So he developed a game like a year and a half ago. So when I told him like, I'm going to do reversing, and he was like, yeah, go for it, do it, hack it. That's what he said. So yeah, so I'll be using his app. Okay, so I'm just going to list down, because some of the information sometimes is harder to find on the internet, so I'm just going to start from scratch. So in this example, what I'm doing is I'm actually pulling an already installed application from my phone so I could get an APK file from it. In order for you to do it, first of all, you have to turn on the developer mode on your phone. And how you do it, you just go to your settings, you go to your about phone, and then you go to your build number. You press that for 6 or 7 times, and it'll make you a developer on your phone. Then once you are in that mode, you just go and turn on the debugging. Also, once you've connected your phone to your laptop, your phone would ask you, what mode do you want to use this USB option in, so you just choose that as a file transfer. And after that, you have to run some commands. So, the demo goes on all my friends, so what I've done is I've just taken screenshots for everything. So the first command that you would run is the ADB. So you can see now I will be referring to those tools that I've listed, and that's what I will be using in these screenshots and in the slides, upcoming slides. So ADB shell, so this will help you list down all of the packages or the applications that are already installed on your phone. So output will look like this. So all of the applications that you have already installed on your phone, you run that command once your phone is connected, will give you all of these packages. Okay, so you will have to find that APK path that you're pulling from your phone to your laptop for analyzing, for analysis. So you would do ADB shell PM path, you give the path of the file, and after, once you figure that out, you will pull that file running that command. And that's what it sort of looks like once it's been pulled. You could see the data's been transferred. And the previous one just sort of gives you the information about the app. Obviously, all of these commands will be made aware, in the presentation slides, so you can, feel free to use those. So once I pull the file, as I said, APK file is actually a zip file, and all you have to do is run unzip command to unlock the contents of the file. And that's exactly what I've done. So I'll just ran unzip, and it started extracting all of the files, what's inside in that APK. So by default these days, when you are using Android, all of your APK files are named base.apk, so that's why you see base.apk, and unzip is the command to unzip the contents. So once I've unzipped it, I just wanted to see what's inside, what's actually been extracted. and all of those files have been extracted, including the Android manifest. Assets base is obviously the APK file, classes.dex, which is the ZAR file, and all of that. Cool. So let's open the Android manifest file, right? Because now we have unzipped it, and it's ready to go. And that's what we get, because it's still in a binary format. We haven't decompiled it. All we have done is just unzipped it. And that's where the tools that I talked about, like APK tool, comes in handy. So we have to do it properly. We have to decompile it. And you will run the APK tool with the D parameter, which means decompile, and you give the name of the APK. So it will decompile it. Yeah, so we've got the decompilation, because that's good to see once it's decompiled. And again, like now I've listed the contents here again for what's been decompiled. Same files. And now, once it's fully done, once it's fully decompiled, and I can see the files in there, now let's try one more time opening Android manifest file. And then you'd be able to open it. And here, what I've done, I've changed the parameter of debuggable from false to true. So I think since probably from last 5 years, you can't publish any app to Android App Store if you've got the debuggable is equal to true, because they would always put it to false, so no one be able to run your application in real time running a debugger. So the only way you can do debugging, open the manifest file, obviously decompile your zip file, get to the manifest file and change that option to true, then repackage it, and then you can attach that to a debugger if you want to. Yeah, you can also get a jar file from an APK using dex to jar. All you do is you just run that dex to D2J or dex to jar, and you give your APK file, and then it will give you that base-dex to jar file format. And then what you do, you use JD GUI, and you can view that Java files in there. So here you actually gonna see, and you're gonna make, you can't make changes in JD GUI. So here you just look at the code, and then you go back to Smali and make changes there, because this doesn't allow you to make any changes. It just let you view the jar files. Okay, so we've made our changes. So in my example, I made a few other changes as well. So it's time for us to recompile our application. And for that, again, we will use APK tool, but now with the parameter B, because now we're building the APK, and you just give that folder name where your files have been extracted in the very first step, and then it will build all of our APK file back to an APK. And now, as you can see from the steps that are listed, once you have rebuilt your APK, you have to sign it and you have to optimize it. So in the next step, I'm using the sign tool to sign my APK. Once everything is fine, and I'm just using a test Android certificate, and you can see it has signed my APK that I had modified, and it's ready to go now. And before it's ready to go, I just want to make sure that I have optimized it, and I've used Zip-Align for that. And Zip-Align is a tool that comes as part of Android SDK. You can use that to zip-align your application before you push that to your mobile. Okay, it's time to install it. And we will use ADB for that. And I'll just run a command, ADB install that package, and then that will install the package on my phone. And the end result, if you remember the name of the application in the very first step, and now. So that's what, like, the changes that I made. So I've changed that to what I wanted it to be. Yeah. So, but again, like, you can do so much. Like, I'm not going to show you like what other stuff I found, but this is the key process in the steps to disassemble and again then compile an application back into APK, and then how to push that to your mobile. So the last section that I have in the application, in my talk, is how to secure your application from reverse engineering and how to make our life harder. For that, there is a tool called ProGuard. So ProGuard helps you obfuscate the code that you're writing. What that means is, for example, you've got your actual code or the source code on the left, and when you run that through ProGuard, it actually creates a completely it doesn't make any sense kind of code on the right-hand side. So it looks at your methods and just convert them into some random characters. So it sort of obfuscates your code. And when you're reading this code again in Java, it's not going to make any sense because you just can't keep track of that. Yeah, so it's great to run your code through obfuscator and use this instead of just leaving your actual source code there. Developers can also do this manually by looking at the code and finding those areas which are really important to your application. You can encrypt it, you can hash it, you could, again, use some automated tricks to do that. Some other few things that I've put in there is please don't store any sensitive information in your source code. Obviously, if you really want to use your application for some critical functionality, just move that critical code from your app to your backend server, because then at least if someone managed to compromise your application, they won't be able to see that sensitive information. But then again, moving that code back to the server side has its own impact in terms of performance, so you have to be very smart about it when you sort of choose to do this. Again, don't hard code any credentials in your applications, including API keys, your secrets, your bearer tokens, and whatnot. Please don't do that. And again, if you really want to use API keys, just use public cryptography, use public and private key combination rather than just hard coding your API keys in the application source code. And also, don't store any app data in external storage, because then obviously every app that you have installed on your phone will also have access to that data as well. And this is my favorite, implementing anti-tamper and anti-debugging techniques. It's like writing a safe code into your source code. So every time if someone is trying to debug your application in runtime, your application can go into a very limited state where it will sort of limits its features and will start crashing. So whoever is trying to debug your application in real time won't be able to do anything with it. Yeah. I've also put some further readings. There are some really good resources available on OWASP's website, especially around reverse engineering. And some of the research that I've done for this presentation has some, these are some useful links as well. So you could go and have a look at that. Thank you.